What the? I'm so confused. All right. No one else is watching. About to work on this. Do 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 do. Need some music. You know, I was watching the past broadcast and my typing is freaking loud. I heard the background music is actually loud too. So I'm just gonna... I don't like that one. Someone out there is working harder than you right now.
On the street, no branding, on purpose no branding, because we didn't want any boundaries.
Just joking. You're probably working really hard, probably harder than a lot of people. I'm gonna start working on this soon. Let me know if the sound is weird. Oh, be right back. Let me know if things are getting a little choppy out there, or even my sound is a little weird. But I'm gonna move my mic because I heard the typing is super loud. Ooh. This is so ghetto, I'm sorry. I'm really sorry. Oh, this is ghetto. Alright, whatever. Like, I'm just gonna put the mic over here. And I apologize preemptively that my typing is going to be super loud.
Your living organism and all its behavior. It's expressing it as a singer.
Here. Well, we're starting in 3 minutes. I know it took me a long time to just get things started. I didn't even save this, did I? I still have this left. My coffee's pretty good. I think I'm gonna start now. I mean, it's already getting a little too late. Okay, so first of all, the way we last left off was that we basically reformatted the data so that we could actually perform exploratory data analysis. So I think we finished step 1, which is basically just munging, cleaning data manipulation, and whatnot. So the new all right, I gotta do all this first. So the new data frame is, one sec, it's called new combat data. Oh, I shouldn't have done that. There we go. So this is new combat data. What we did was that we just basically combined all of the metadata attached with the unique identifier for each Pokemon. And I believe this is good enough for now. And now what we're probably going to figure out is, let's see here. Let's see here. Really? 4,500? How lower the better. Really? Video output too low. Let me start over again. I'm gonna. Okay. Hopefully it'll work this time. Sorry about that. Let's see here. Apparently the stream health is good now. Okay. This is going to be a little slow right now. Alright, so we've definitely worked on this. So we have the head of the new combat data. We combined all the metadata into one vector for one Pokemon versus the second Pokemon, and we've also attached a dependent variable, which is the winner. So we have X named type 2, all this stuff, and X2. What we want to do now is to come up with certain questions. Some questions would probably be, let's say, is there a linear relationship between certain, I don't know, certain features or independent variables? Are there any correlations? Oh man. Of certain data sets, or any correlation between the features, and are there any, let's see, are there any data types? Or no, not data types. Is there any features we don't need? So when I mean by asking questions, like, can you come up with certain assumptions that could tailor towards a specific algorithm? So let's say, like, in linear regression, I'm not saying that there's any there might not be any linear correlation between anything, but and plus this is a categorical variable. Okay, maybe the bad example. Let's use logistic regression. Logistic regression, you know, you can predict an outcome using binary categorical variables, and it predicts linearly using a log function, right? However, that's the weakness too, because you're sometimes automatically assuming that there could be some sort of relationship between the dependent variable and the independent variables. Another good question is, like, let's say, okay, here, if we were to use logistic regression, we have to know the assumptions for logistic regressions first. So, binary requires the dependent variable to be binary, which is correct. That's a hard pass right there, or not pass, a hard qualification right there. Logistic regression requires observations to be independent of each other. Okay, so what that means is that there's absolutely no correlations, no correlations with each other, if at all. If something goes up, basically, or goes down, like if the value increases for one variable, then is there another variable that also goes up or goes down? You know, is there a dependency of one another? Another word for that is shit. I think another word for that was what is it called? Dang it. It's not correlation. It's something else. What is that word? It's a common word. It's like let's say two animals depend on each other, like especially in the aquarium, where you kind of see like certain fishes that attach a bigger fish. What is that word called? Symbiotic relationship. Symbiotic? Dang, now I'm like amazingly pissed off. I'm so bothered by not understanding what that word was. Maybe it's not symbiosis. That's not right. I studied this, and everything is escaping from me. Don't you hate when that happens? Oh, man. I'm very close. correlation. It's something else. What the heck? It's in this book and I can't find it. And it's in this chapter too. Synergy effect. The interaction effect. That's what it was. That's what it's called. In other words, the observation should not come from repeated measurements or matched data. Still don't know what that really means, but anyways, it's independent of each other. Basically that there should be no dependency on one feature over the next feature, because so for example, like let's say you have a measurement of an arm, you know, but then another column would be like measurement of a bicep or something like that, right? Well, an arm is part of the bicep, so if you're already in there, there's already like a dependency of the bicep anyway, so you might as well just get rid of the arm and try to just get us the most specific part, such as the bicep. So the bicep depends on the measurement of the arm because the arm is already measured, you know, and the bicep is part of the arm. So that's what it means by dependency. Like if there's some sort of like data type that depends, and if there's some sort of attribute, and then there's another attribute that actually is part of that other attribute, that's the dependency. That's something that we shouldn't do that. Now independent might be like eye and finger or something like that, but whatever. So the third assumption is that it requires to be little or no multicollinearity. Yep, I kind of said that, or I said correlation, but multicollinearity is that there might be a correlation with each other. The reason why that this is bad is because if it'll really skew the results if one of the variables and another variables is kind of directly correlated with each other, like directly like the same thing, or like, I want to try to explain it very well, so I'm going to type in correlation. See, it'll even say data correlation will make or break. Yeah, well, correlation refers to a mutual relationship or association between quantities. Why is it a useful metric? It can predict from one quantity to another, but logistic regression can't do that because it just doesn't calculate that way. Logistic regression uses like this method called the maximum likelihood, where it just most likely maximizes the average prediction, the chance of what it can be. It's either one or the other. Attempts to find a parameter values that maximize the likelihood given the observation with also Emily is used a wide range of statistical analysis. Yeah, that is a poor definition. Obviously it says maximum likelihood, so it maximizes the likelihood function. What is the likelihood function? I really don't like that terminology for some reason, maximum likelihood. Assumes that the statistics for each class and each parameter are normally distributed and calculates the probability that a given pixel belongs to a specific class. Anyways, that's what logistic regression is. If there's no multicollinearity, observations tend to be one or the other. Let's see here. It typically requires a large sample size, which is good because we have 50,000. I think that's good enough, right? You need at least a minimum of 10 cases with least frequent outcome for each independent variable in your model. If you have 5 independent variables and expected probability of your last frequent is 0.1, then you would need a minimum size of 500. Whatever. Anyways. So it seems like it passes all the assumptions almost. Logistic regression is probably like the best way to do this. So I'm gonna cheat a little bit. I think we've actually, what we're gonna do is, number one, check if there's gonna be any correlation, because if it has some multicollinearity, then I don't think that's a good thing. So one part of the EDA, check any correlations. So I think it's really simple. All you do is just type core and then new combat data, and it kind of provides a visual matrix. Oh shit! How does this work? Oh, here we go. It looks like this a little bit. It looks like this. This is just a different example. I just need to find out what the code for this was. I'm gonna cheat a little bit. Let me check something, okay?
Ready to proceed or next, we want that if you choose in the middle to sample a subset of it, extract one
Man, where is it? Man, I'm such a noob now. Let's see here. It's a little frustrating, I'm sorry.
Let's use this.
That's not it either. Is it under linear?
Let's install CSV via of functions of this data variable to this land. The first only going to variable. We want to use about.
So it's not an K in it. Hold on one sec. Oh, it's pairs. Oh, it's pairs. I didn't even know that. Okay. This is probably gonna suck. Oh yeah. Ew. Oh, so it's pairs. Maybe I should take out when this is gonna take a million years. It's still processing right now. Jesus. Holy shit. What? There's some sort of correlation here. Man. Oh, it's still loading. No wonder. Oh my god.
Cross-validation assessment are available and linked to your lecture as well. We can attach the data set to make the names of the variables. Have not already done so, go to your change directory to make sure that you're in the size validation assess or lecture data set of some of the pairs of, even if we enlarge it, well, we can see a lot of correlation with the response that we're ultimately interested in, the body fat series, but really you should focus on individual scatter plots for identifying those correlations.
Yeah, she just said it. Okay, fine. That was a bad idea, doing the pairs. I'm gonna stop this. Do not run. Yes. Holy cow, dude. My R is blowing up. Man, are you serious, bruh? Holy cow, dude. Yes, I want to quit. Save selected. Oh. Okay. Alright, sorry about that. I think we're gonna have to start all over again. Clean this shit up. I mean, not all over again, just resume what we did. Oops, this isn't it. There we go. This is what I need. Okay. I did not mean to do this again. There we go. Are there any multicollinearity? I don't know. Anyways, EDA. Any collinearity? You know what? I could also do the if I could do this, I could probably work on the variance inflation rate or inflation factor to check for multicollinearity.
Once again.
Oh, that's how you use VIF. Okay, never mind. You have to create the model first. I guess it really doesn't matter because we're gonna have to use that stuff anyways. Why is everything so choppy for some reason? That's weird. What maybe we need to do a little bit more cleaning of the data. You know what? Let's make this a little bit better. So for culinarity, so here's my thought process. Sorry, I went off. I keep getting into the rabbit's hole too much. So any culinarity, we check the culinarity within BIF. But that's after we create the model. Now, you know what? Let's take a step back. I don't think we're gonna do EDA yet because I just realized that, man, I'm such a noob. I realized that there's a lot of names and type 1 and type 2, and they're all like words. And I was wondering if I could just easily categorize them within numbers. So let's say like grass is class 1, rock is class 2, psychic is 3, dragon is 4, you know, for like types. There's also like different types for type 2 as well, like dark, fighting, rock, ghost. Now so a deeper question is that is this necessary? But I think I'm going to the rabbit's hole again. Hold on one sec. First of all, what? Oh, I did something wrong. There we go. I'm really confused, so do we... So I think am I supposed to vectorize text data to numbers? It's kind of, or can I just use this? Man, I totally forgot how this works. I'm gonna ask these people. I'm gonna ask some questions, man. This is kind of tough. I knew it. So you have to, to train supervised classifiers, we have to transform consumer into a vector of numbers. You have to transform those things into numbers instead. Oh man. So we have to do that, don't we? Ah, shit. Okay, so we just realized that, okay, I just read something online where we really do have to vectorize, if we want to do a supervised classifier machine learning algorithm, we do have to vectorize this. So we haven't started EDA yet. We still need to prepare our data still. So continue to clean data, prepare data. So what do we need to do now? Vectorize all the types into numbers. So representing each class into a number. Class name into a number. So what I mean by that is that if we have new combat data, I think it's levels, but yeah. So we see that there's different types of Pokemon types. Yeah, so if we see some type of Pokemon types, yeah, so if we see, it'll have like, we need to convert that, we need to basically vectorize that into numbers with these different Pokemon types. So in order for us to do that, I'm kind of learning as I go when I do this. So there's 18 levels, so I remember this. I forgot how to do this though. Hold on one sec. So let's see here. Remember I watched this one video that I really liked.
We'll start off with groups, repeating 1 up to the number of groups, almost the total number of observations times. So here we notice that if we take a look at the data set, as we did before, it has 252 observations, but we want to have 10 folds, which means that we have about 25 observations per fold, but 2 of the folds will have 26 observations. So when we define groups, if you want to type in what groups look like, it just repeats 1 through 10. The group labels 1 through 10 25 times, and then tacks on a 1 and 2 at the end. That's what this little function allows us to do, where k is the number of folds and n is the total number of observations as we labeled it up here. Alright, so the next thing we're going to do is randomly assign these essentially by sampling. And we're going to set the seed to be 2 so that everyone gets the same seed.
Yeah, that's not how I'm supposed to do it. Okay, so, god damn it. See, Pokemon type 1 equals C 1 through 18.
cross-validation groups. So copying and pasting this over, if I typed in what my CV groups are, random, the third observation would go into CV groups. So if I were to type, for example, body fat series predicting, handle that if vector. What the value in the full model, as we had before, use the appropriate symbol. We see we've got the original predictions, so the y hats, the y's versus the y hats that we would have gotten from, obviously we don't want to do this just for group 1, we want the reverses the falses to trues and trues to falses and selects the appropriate subset. We're going to fit the linear model. Then I'm going to identify the different groups, and I do that by defining inside a loop for each group something called group I. And this is just a true-false vector, which allows me to call on parts of the data set. So how I would take a look at that is, well, I'd take a look at my first group. So when I equals 1, when I do that, I can define group I in this way. And what you'll see is that it's simply a big old vector of trues and falses. False when the group is something other than 1, and true when the group is what the value of I is, in this case, 1. Then we're going to fit the linear model using the full model, as we had before, using the data set, as before.
Oh my god, man. One sec. Oh, man.
Big old vector of trues and falses. False when the group is something other than 1, and true when the group is what the value of I is, in this case, 1. Then we're going to fit the linear model using the full model.
This is such a weird type of coding. It's weird.
True-false vector, which allows me to call on parts of the data set. So how I would take a look at that is, well, I'd take a look at my first group. So when I equals 1, I do that, I can define group I in this way. And what you'll see is that it's simply a big old vector of trues and falses. False when the group is something other than 1, and true when the group is what the value of I is, in this case, 1. Then we're going to fit the linear model using the full model.
Okay, I think I know how to do this now. Oh, I think I have an idea. I mean, just by looking at this little example here. So here's what we're gonna do. We know we have levels: bug, dark, dragon, electric, fairy, fighting, whatever. I'm gonna put this into a list. So, class, Pokemon class list equals C. I wonder if this works. Oh shit, that works. Are you serious? Oh wow. Okay. And then we already have this is an ugly way to do this. I don't know how else I can do this, but let's do this. For I in Pokemon class list, let me like test something out first before we do something, because this is my first time doing this. Okay. Bug, dark, dragon, electric. Why is it like in quotes? So group I equals, let's see here. If new combat data type .1 equals I. Right, okay. You know what? Before I do this, let's do this. Let's say that's a bug type. I want to see. Let's say group I equals oh wow, there is trues and falses. Okay, that's good. That's good, that's good, that's good. Okay. So here's something that we could do. If there's a Pokemon class list, you know that it's this thing. Now within I, Now let's say they found all the bugs, then you would
dataset as before, but only on the subset where group I is not true. That's what the exclamation point means, not group I.
Okay, I think I fucked up. Damn, I just realized something shit. Man, how do I do this? Really? No way. It's that easy? Oh God. You're kidding me. I don't even need to do all that. Hold on. No fucking way. Can't believe I don't have DPLYR. Oh. That's how you do it, huh? I didn't even need to install DPLYR. Now I have to wait for this crap. Why? I mean, is DPLYR that big? This is gonna take a long time. Oh, come on. God damn it. I don't want to do this. I don't want to. Why is this taking forever, man? Really? Can I just stop? Can't even stop. I hate when that happens, man. No, I don't want to terminate R. God damn it. Why is DPLYR so huge? I don't need this. I don't need this right now. I'm just gonna, yes, yes. Oh my god, bro. Oh, you know what? I'm X-killing this. I don't give a fuck. Jesus, why did that take so long? DPLYR is that long? Man. Okay. Alright, we're gonna start over. We're just gonna change the levels into one thing. I didn't know you could just do as numeric. That's so insane. So rock is 16, grass is 10, fairy is 5, fire is 7, rock 16 again, okay. Bug is 1, psychic 15, bug is 1, sweet. I didn't know it was that easy. As numeric, really. Oh my god. Man, I just wasted like a billion years just to figure that out, and I'm not, and this was just the solution. God. Well, at least I learned something. As numeric, huh? Wow, my head hurts now. I have a headache. Oh man. Oh man. I think I need a break. So I'm gonna take a break. I might come back in 15 minutes. Cause damn, I'm really tired. Like I need to reset my brain. I don't know how to do this like in YouTube. I know I could have an overlay, but I don't even have an overlay, so I'm just gonna do it like this. Oh.
I dig the natural. I think the natural is a beautiful, beautiful way of wearing your hair. All that. Back up in the morning, I'm natural. I know it's that's the way my hair is. I don't have to do this. And black.
Yeah.
Now that is crazy.
de você, moça flor. Te lembrei 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 de você.
Oh shit. Oh man. That kind of took me a while. Man, I did not know I streamed for this long already. For an hour and 48. That's including like everything, so... Oh my god. I didn't know. It was already almost 2 hours long. No wonder I'm really tired. So, not EDA yet, so I think we need to vectorize other things as well. Now we have like, let me see, what's levels in combat data? Type 2, what's that? There are some data points that have null data. Damn. That kind of sucks. Well, that's interesting though, actually. It sucks, but it's also interesting. So I gotta apologize. We're not even there at EDA yet. We still have to clean up a lot of data. So I think that's the level of how much data that needs to be cleaned, even though there aren't any. So in type.2 features, there are some null data points. Question is, should we... I don't want us to delete them, but what do we do? I don't want to delete the Pokemons that doesn't have that has some null data. We could fill it in with anything, right? Like just any fillers, like NA, X, 0, ground points. I'm gonna have to ask this, like, what do I do with the null data? And so this is actually kind of interesting. Let's see here. We could do like a quick analysis though, like see how many X must be numeric. I didn't know histograms have to be numeric. What about bar charts? Oh, bar plot. Alright, let's just do that then. Holy shit, there's a lot of NA. That's gotta be NA, right? Oh, yeah. So there's 386 NAs. Ooh, what do I do with that? Wait a minute, I don't get it, man. This doesn't really add up. There's 50,000 rows of data, but I'm so confused, man. I did not know there's this Pokemon that only has one type of Pokemon type instead of two. I guess that makes sense. Oh man, damn it. Oh my god, man. What I don't get is, like, how come there's only this much? There should be, like, a lot. That doesn't make sense to me. This does not equal 50,000. That doesn't make sense. Oh, here we go. That didn't make any sense for that. This is more like it. This makes so much more sense. So there's 24,000 that has X. Null data. I guess the only way is just to, yeah, I guess we just gotta say that the null data just represents 1. Oh, that's interesting, though. Yeah, C1, meaning that there is no... Okay. I'm gonna have to put that down somehow. This is actually kind of like my least favorite part, so I have to do it for the other two, and then we could... I don't think we need legendary. I don't want legendary. I know what legendary is, if it's a legendary type of Pokemon. Or do we? That's a good question, man. Oh! 9 o'clock. I just had to rename that. Anyways, we're gonna have to do it the same for 1, 2, and 2, 2, and then I think we're gonna call it done because that took a long time for me to figure this shit out. This requires just too much thinking, and I'm really tired already. So we have a ton of we have a mess ton of headers now. I guess that's unavoidable, but it's okay because we can actually just select some of them instead. We're probably gonna have to convert legendary as well. Yeah, let's just do that. Holy cheese. So 1 is false, 2 is true. Okay. Alright, I'm done, man. I'm tired. I don't feel like I've done a lot. It's not efficient enough. I'll work on the efficiency. And I think part of my big problem is that I'm always like getting sidetracked way too fast. It's like my attention that's like bad attention span or something. Anyways, I'll talk to you guys later. I'm done.